Hello, hello. Welcome back. Today, I want to add some parallax scrolling to my game. Because right now there's just this black background, right, which is a bit boring. So I want to add some kind of background and some depth to it. And parallax scrolling is basically, I have an example game here. You can see that the background trees here, they basically move slower than the foreground, right? And it gives the illusion of depth. Yeah, even though it's a 2D game and whatever, they're still utilizing the third dimension to some extent, right? And that's what I want to do as well, right? So that's the goal. However, I first want to fix a big hack that I did last stream with the debug rendering. So the game right now runs at a fixed tick rate. Right now that's, let's see how fast that is. It's 60 Hertz. So we update the game logic 60 times per second. Right, and the problem with this is that if we have a good GPU and can render faster than 60 times per second, then this tick, there will be some frames where the game doesn't tick, right? And why is that a problem? Well, inside of this game tick functions, I do some debug rendering. For example, this box around the player I think is rendered, and this like impact collision point is rendered. So we've kind of fixed this or worked around it by just making the rendering slower artificially. We just sleep here for like 20 milliseconds, right? But that's not a proper fix, and yeah, I mean, it just feels terrible to like do anything because it's laggy. It's horrible. So I want to fix that somehow. So if I actually disable that, I think it's kind of hard to see, but these dots are now flickering because there are a lot of frames where the game tick doesn't run and like fills actually draws these points, right? Yeah, so I want to fix that somehow. But yeah, so this box is still here, right? And that's the exact same debug rendering. But the difference is that this box is drawn outside of the tick function. I think in the render function. Yeah, we have this draw debug box and draw debug cross, right? So that actually is like submitted every frame. So that's not an issue. The only issue is this tick, the things that are being drawn in the tick. And I think basically the way I want to solve this, I think, is to essentially have two buffers, or at least two regions of the same buffer, where one part of it contains everything that's submitted during the tick function, and then after that I just append like stuff that's submitted every frame. And I guess this first buffer, I just want to clear that before every tick. So what will be in this buffer is like all the debug lines or whatever for the last tick. And then after that I just append everything else. That's like appended in these render functions. So let's take a look at the debug renderer, how it works right now. Alright, so the actual right. So when we draw something, we have this line count. So when we draw a line, we just append these vertices to this line count. Let me think. Yeah, and then when we draw it at the end of the frame, we clear the whole buffer. Okay, so let me think. So I guess I think the interface we basically need. We need some more information, right? Some more information in this debug renderer. So what was this called? Yeah, we flushed the debug renderer. We basically need more a more flushed out API here. So let's see what that would look like, maybe. So yeah, what I'm thinking, okay, so when we actually, or before we do a tick, we basically want to completely clear all of the buffers. I think that makes sense. Or I guess... Well, right, so there are a couple of cases. So let's imagine that there is no tick. Then we still have to clear the per frame buffer, right? So, and we already have a call here, so maybe I can actually maybe I can just use this function for that for now. And I imagine we also need one in here, because if we can also tick multiple times in a frame, so we want to clear it before each tick. So if we do 2 ticks, for example, we do the first tick, and then I want to clear it again, and so that we basically essentially have the state of the last tick, right? So in here we should only clear the per frame debug stuff, right? And in here we should clear the per tick debug stuff. And I guess one really annoying thing, this is still using the old naming conventions. Well, I guess it's a bit mixed up still, right? Because I want to use this convention. So I guess we can start with that, have something like debug renderer flush, right? And then something like debug renderer begin tick, maybe, or start tick. No, begin tick. Let's call it that. And I think all we need is basically the debug renderer state, right? So we have the begin tick, and we have let's call this other one begin frame, and well, we can rename this one actually, because it was called at the point where I want this at. So that would be something like debug renderer begin frame. Yeah, let's call it that. Right. Let's call it that. So we have the begin frame now, and the begin tick. Right. So what we want, I guess we need some notion of, we basically need 2 counters, right? Because it's not only the point count, like the line count. We need the line count for the tick stuff, and we need the line count for the frame stuff, right? So I guess actually the easiest would maybe be to just duplicate all of this data. I wonder if I want to do that. Yeah, I guess let's try to do that. So we'll have something like something like a debug renderer buffer. And that will contain all of this stuff. So what we basically, all we have to do, I think, is just to have 2 of these now. Which will be basically, I guess, the tick buffer and the frame buffer. Something like that. Right. Something like that. Oh, I didn't make this. Oh. Okay, I want to change this as well. I want this to be anonymous. Well, yeah. The debug vertex still has to be in here, in the header, but we can move all of this in here. And we'll just forward declare the actual debug renderer. And we'll change this API to actually return the debug renderer instead. Like that. And we will allocate this in here, right? Let's do a C alloc so that it's 0 initialized. Is that? Oh, oops. I think that's the right. Yeah, right. Like that, and then the difference, I guess, is yeah, we have some error checking here. So let's return null instead if anything fails, and then in the end return the debug interface. Right. So now, yeah, let's move this into function. So something like let's make that return error, I guess. So we'll have like debug renderer buffer alloc maybe. And we'll pass the buffer instead. Like that. And yeah, we'll need a config here as well. Right. Tick buffer first. Config. And the frame buffer. Like that. So that's initialized. Yeah, let's not care about destroying. Who cares? Who cares? I didn't even do that before, so. Alright, so now the difference. What's the difference here? Right, we copy this buffered data into the GPU visible host memory. Right, so I guess. So where do we allocate this? Because now we have 2 of these buffers, right? So we basically max frame vertex. Is this a separate? Is this a separate one? This should probably be using the config thing, right? Okay, but okay, let's not care about that for now. So okay, so I guess what we want to do instead now is copy both of these buffers into the staging memory, right? Right. Yeah. So let's see how that would work. Maybe we should make this an array actually. Maybe we should do that. Well, we can do that in here for now. So we'll have something like debug renderer buffer. So we'll have two buffers. We'll just do this tick buffer and the frame buffer. Right, and we should, we probably have to loop through this, right? So what's this total vertex count used for? Okay, it's just for, as an early out. Okay, it's just an early out. I guess we could keep that. So we'll instead just initialize that, like so. And here we'll loop through all of the buffers. Just the count of, actually. Alright, and for each buffer, let's do this calculation again. Alright, so now it's in the buffer instead. Like that, yeah. And then we can still check this here, right? So that's some kind of early out check, right? And then inside of this loop, I think we will also do this copying. So let's see. And if you just copy these, wait. Right, so what we're doing, yeah, we're putting all of the points and all of the lines and then all of the triangles. So I guess the easiest would, we can still do one draw call, I think. So what, I guess we have to do this in two passes, kinda. So we'll have something like the total point count, right? So the point count and the line count and the triangle count. And we'll just have to accumulate these in the first part here. Like that. Then we know how many vertices in total to append for each one of these. Right. And then let's see. It's probably gonna be easiest to. Yeah, it's maybe easiest to, let me think. Yeah, let's do something like debug vertex, because we're filling debug vertices here. So let's say we have point vertices, which is going to be just the start of the staging buffer, right? What's the issue? wait, frame. Oh, the frame is here. And okay, we can do this early out immediately here. Okay, sure. Right. So we have the point vertices that we want to fill, and we have the line vertices that we also want to fill. And this is offsetted. Yeah, it's basically the same calculation, right? Except I'm just offsetting the pointer directly. So that's going to be the total point count. And the triangle vertices are offsetted by the point count and the line count times 2. Because there's 2 vertices per line. That makes sense, right? And then we have to loop through the buffers again, and now we can actually, now that we know the offsets, we basically did a prefix sum, right, in essence. So now we know where to actually put these vertices into this buffer. So now we can do these mem copies, but it will look a bit different, I guess. So the actual offset now would be, so for the points, it's just this point vertex, point vertices address, and the source is going to be the buffer point vertices, yeah, and the point count. Oh, point count, like that. And all of this, the rest should be simple as well. It should be identical, I think. So that we have the line vertices. We want to copy the line vertices into that. This is the line count times 2. Yeah. And triangle, same for the triangles, but times 3, because there's 3 vertices for each triangle, right? And then all we have to do now is just move this forward, right, for the next mem copy, and that should just be the number of vertices in this buffer, right? Point count, like that. I think that seems reasonable to me. And maybe actually, so we have this offset. We have this offset, and maybe it's good to still have this, because I think we actually need this, yeah, for the vertex buffer, right? So we should take this as well. It's gonna be the same as these offsets. Yeah, so that's 0. So we can essentially, I guess, just do this. So it's point count, line count, like that. And instead of doing it again here, we can just use these offsets now, like that. Maybe it's nice to align it like so, like so. Maybe. Whatever. That's pretty. Alright, because we need these, yeah, for this calculation, right? So, yeah, now it's just this point count, the total counts. And we should not reset any buffers here when we're done rendering. Yeah, because there is the case where there is no tick, right? And then we want actually the debug data, visualization data from the last frame, from the previous frame, basically. So we should not reset it here. Yeah, and now also the difference here, I guess, is that we need to know the current buffer in which we should append this debug rendering to. So that's going to depend. So like inside of this ticking part, right, of the frame, that should be the tick buffer, obviously. And then after this is done, that should be the frame buffer, right? So I guess we also need some kind of function here to call. Maybe we could make that separate, have something like a yeah, we could, let's make an enum for this. So we'll have something like debug I already took the debug renderer buffer, right? Debug renderer buffer. Type, no, but it's not really a type. It's like, let's call it ID, I guess. So that would be debug renderer buffer. Let's call, yeah, that's tick and frame. And we can have some API to just tell the debug renderer which one should be active. So like which one to append the debug stuff to currently. So debug renderer set current buffer. Yeah, let's do that. And we should, oh, we can use this internally now as well. So instead of having to name the like this, we'll just have buffers, and we should have that many. I think that makes sense. And we could do loop now. Like that. And now we don't need this anymore. And we can use this now here as well. Yeah, and just access this directly, right? Makes sense. Like that. And this set current buffer, and let's implement that. That is going to be very simple. So I guess we don't actually need the debug renderer itself anymore, right? We just need this debug renderer buffer. Because all we're doing in the strong function is just appending to this buffer. Right. Let's call it current buffer is fine, I think. It's gonna be used in this in this file. So when we just set this so like this, right, and we need a debug renderer here actually, like that. So we just pick out this buffer, basically. That's it. So that's like the current buffer now. And now when we are drawing stuff, we just take this buffer. And do I actually need to? I can just use this directly. I feel like that's fine. Like the current buffer. Okay, there is some kind of... there is a limit, right? That is slightly annoying, but let's just... We can just move that into the buffer also. It's gonna be a bit redundant, but it's fine. It's fine. So instead of setting these in the debug renderer, we just grab them from the config, right? Oh, I guess we can do that inside of this alloc function. Okay, so now we have that here. Right. And Okay, I think actually I do like if I just like pull it out. It's like shorter and nicer of that. Like that. Okay, now we just have to add these calls, right? And maybe we can even make it, let's see. So set current buffer, right? And we have debug renderer. Oh, and also this changed as well, right? It now returns it from this create function. Like that, so we have the pointer. We can also make sure that succeeded. Right, so after the ticking is done, we want to set the frame buffer, right? And here we want to set the buffer tick buffer. And I guess we can do that. We can do that before, right? So what I think, I guess all we need actually, we can make this a bit less. I think all we need to do, we need some API, I think now, to, let's see, so at the start of each frame, we should clear, right, so I guess we can have something like a clear buffer, and we can do the same thing, so we want to clear the frame buffer every frame, that makes sense to me, and before each tick we want to clear the tick buffer. That makes sense to me. So if there's no tick this frame, then it will still have the data right from the previous frame to render. I think that makes sense. So yeah, all we need is this clear function, right? Instead of this begin tick and stuff. Yeah, we should specify the buffer. Instead of those. And what's that gonna look like? I mean, we need the buffer at least, and that's, I think that's extremely simple, right? We just set these counts to 0. So for the points and the lines and the triangles. That's it, basically. Now that's cleared. Let's see what happens. Right. Now this is a pointer, right? So I shouldn't take the address. I probably do that in a lot of places. Yeah, pointer already. Begin frame. Yeah, that's not. Wait, begin frame. Was that doing anything? I don't have it anymore, so I don't think I need it. Okay. That's interesting. So something is wrong, obviously. Okay. What could the issue be? Let's see. So it's only broken when I... Yeah, so when I draw something in the tick now, I think if I'm not on the ground, I don't think the tick, nothing is being rendered in the tick then. So that's the problem. So okay, so if both buffers have some data in them, it's wrong. Okay, let's first check if I got this correct. Clear the frame buffer. Set the current to tick, set the current to frame. Clear it. That looks fine to me. Looks fine to me. So there's probably something up in here when we're flushing this. This is fine. Seems fine to me. Like, yeah, this is the total point counter for both buffers. That seems fine also. Oh, right, we also have to multiply these by, because these are the primitive counts, right? Yeah, and the line has 2 vertices, triangle has 3 vertices. That should be it, I think. Yeah, so that's working. And did I actually... Yeah, I did remove my sleep. Okay, that's good. So that's working now. So I guess actually... I wanted actually... I should add some kind of debug function to like disable the game logic tick. I think that's could be useful actually. And that's would be an easy way to confirm whether this works also. I mean, it seems to be working, right? Because then I should be able to pause the tick, and this like debug rendering state should remain until I continue, right? So let's add some key for that. I guess there is a like pause button, right, on the keyboard. Maybe that's nice. I can use that. So we can have something like, let's call that pause, maybe. Sure. And I think we actually need to add that key then also here. So we need the key pause, right? Pause break. And we have to find the X11 key code. That's probably right. So that's that. Right. And then we have this event polling here, right? So we can now just check it here. So if the key code is key pause, we just pause it like that. And then I think we still want to like update the accumulator. Or wait, I guess an easy way of pausing is just not doing this, right? Not updating the accumulator. Maybe. Okay, so if I pause, yeah, I can't. So now I can pause the game logic. Yeah. Oh, and yeah, the particles are also paused. because, yeah, because they are actually updated in the tick function. I forgot that. Okay, that's pretty cool actually. So I can pause the whole game logic. Alright, and the debug rendering obviously works as expected now. That's good. Cool. Okay. So that's like fix debug drawing inside game tick, basically. All right. That's that. And now I can actually start adding some parallax scrolling. Yeah. So for the actual contents of the background, I want it to be the same as this, right? I want it to be polygon based, right? So I guess what I need, or what I want, is just I need some notion of a parallax layer, right? So we're gonna have some number of parallax layers, and as a start, we can just have a single polygon per layer. Yeah. Yeah. Okay, because right now there's also just a single polygon for the whole world, basically. So we can start with that. Right. And and like the vertices I'm using for rendering here in the world HLSL, right? I load the vertex position, and that's already a 3-dimensional coordinate. So that part should be fairly simple. Like all I have to do is change the z coordinate, right, of every single vertex in the polygon. All right. But to start off, we should probably have some notion of a parallax layer. That's probably gonna be kind of global. I'll put this in the common header. So we'll have something like parallax layer count. Let's start with 2, actually. And what do we have to change here then? So right now we have this editor polygon, right, which makes up the world, basically. And that's the thing that we can drag around here, right, and add vertices even. So that's the editor polygon. So we want multiple of those. And I feel like we basically want each one to be basically contained within some kind of layer, right, structure. Because I guess one alternative actually would be to just, for each polygon, it could know its own layer, right? That's one option. And maybe that's nice, actually. I mean, it really depends on how you want to use this data, right? Or how you want to access it. But for now, actually, for now, let's instead have some kind of notion of a layer, right? So we'll have something like a parallax layer. And in that layer, we will have a polygon. A single one for now, right? So the only difference then is that Wait, I'm in the wrong. This should be in the C file, right? So the only difference would be that right now this world struct, that's the like whole world, right? That has a single polygon. So the only difference now, I guess, is that instead of a polygon, we're gonna have some layers, and that's gonna be the number of that we specified here, right? The parallax layer count. Right, and this is gonna require some changes, right? So for a start, I guess one issue is gonna be, I guess one question, like right now, I actually saved this world state in a file, right? Inside of the, what's that called? World.bin, right? And this is just a binary dump, right? A binary serialization, I guess. And the question is, do I want to be backwards compatible, right? Do I want to be backwards compatible? Because this file doesn't know about parallax layers, right? It's still in this world where there's a single polygon for the whole world. And I don't really feel like it's worth it, probably. So if I actually remove this file, so that there's no data to load. Oh, my GPU crashed, kinda, almost. Okay, so if I delete the file, so that there is no data to load, then we get this thingy, and this is basically, this shape is defined in code, right? So when we create a world, we create this, this, I guess, pre-defined polygon, right? Hard-coded. So I think it's fine for now to just keep this the same, and yeah, I won't bother with loading like an older version of the world, right? So instead of this now, I guess we just initialize every layer to the same, with the same polygon data. That's fine. I guess the boring thing is that right now there's no perspective in this, right? So, oh well. It would be nice to have some kind of different geometry for each layer, but whatever. So instead of this, we'll have the layer polygon, right? So now we're initializing each layer to the exact same geometry. Fine. So what is this? What are we using this for? Right. Oh, this is spawning these white particles, right? This ambient stuff. So for now, let's just use the first layer. Actually, let's use the first layer. So there will be no fancy particles in the background for now. Right, and here we are initializing the colliders based on the polygon. So we are triangulating the polygon, and that should just be the first layer, right? Because we can only walk on this foreground layer, at least for now. So let's just take that polygon. We can pull that out here actually. Take a reference to that. Right. So that's the only polygon that we're gonna have collision information for, and I think that makes sense. because the player only exists on a single plane, right? At a single depth. Alright, now this is gonna be different though. And I think this is gonna be very simple, actually, a simple fix. So here we are actually generating the rendering data for this polygon. And we are also putting the flowers here in this function. We have this grow plant function, right, which basically just adds the triangles for the flowers and the grass, right? So I think literally all we have to do is just go through every layer here and call this function for each layer. I think that's literally it. It should just work, right? Because the state is contained in this context, and it should make sense, should be fine. Polygon. Right, that's that. So now we will get triangle data for all layers. That's fine. Right, and now. Now. I guess now it would be nice to actually put the number of parallax layers into this file, just to know it, right? Yeah, let's do that. We'll call it layer count, right? And that's going to be the parallax, even though it's a constant, because if I change this, I want to know, like, and when I deserialize it, I'm just gonna assert this basically, right? So we write out the number of layers, and then the difference here, I guess, is that we're just gonna go through all layers. Like that, and write out each polygon for each layer. That's it. That's it, and here, yeah. Wait, where the polygon count? Oh, I was thinking the same thing before. Okay, I guess we can use the polygon count and just set that to that instead, right? And then when we read it here, we want to assert that it's the number of layers we have. Sure. Sure. And then the same thing here, we want to load the actual data for each layer instead of a single one. That's fine. Alright, and now... right, I think actually if I... And this isn't really used right now, so let's ignore that. Let's ignore that. Now, though, this... Okay, I mean, good thing that I already prepared this struct to have multiple polygons. Right, I wonder how the editor is gonna behave, actually. But let's... Okay, so the polygon... let's make this a list of pointers, I think, because we don't have them in contiguous memory right now. Or we do actually, but I'm not counting on that staying the case. So, alright, so then we need some kind of temporary storage, right? Let's do that like this. Well, yeah, let's just do it like this. So we'll have we need a memory for this. That's gonna be like This feels a bit horrible, but and then we can just pass that, right? And then we just have to fill this. Well, parallax layer count, and just collect these into here. Like that. Oops, have to build it. Right, and now in the editor we changed this, right? So 182. Right. Okay, so for now, actually, let's just. So apparently I didn't add support for modifying multiple polygons. That should be easy though. But for now, let's keep the behavior the same. So we're picking the first polygon, which should be like the frontmost layer, right? So, right, okay, I mean, that's a good first step. So there is actually 2 layers now. I was though expecting this layer to be in front, but I guess one thing I forgot, okay, and also, let me save this world. So I saved it now with the hotkey, and if I start it, that's not good. Wait. Is that because of the world? So if I remove the world again... Okay, that works. Oh, I think actually maybe I messed it up too much. But, okay, one thing I want to change first anyway is that I'm editing layer 0, layer index 0 right now, and it appears to be behind this layer, right? And that's the wrong order, and that's because I didn't actually set the depth of these vertices yet. That's the reason. So I just... It's just because of the order now, because triangles that appear later in the vertex buffer, right? Those will appear on top of older ones. That's just how the GPU operates, right? So the depth is determined by that right now. So that should be an easy fix though. So here in the world where we actually fill this primitive data, we need to know which layer this polygon is at. So let's just pass that. We'll have the layer index, right? And we have that here by virtue of this loop, right? So we have the data now, and using this layer index, we have to set a different depth for each vertex. That might actually be a bit annoying. Oh, maybe not. Maybe not. Okay, so we want something like the depth, right? And it's going to be dependent on the layer index. And right now, actually, it's like a floating point value, right? So we just divide this by the parallax layer count. Oh. That makes sense. So we want to be in the range 0 to 1, right, with this value. From 0 to 1, because this is going to be directly written into the depth buffer, and that's what I'm thinking at least. So yeah, this is where we set the position, right, and we just set the depth here. That should be fine. Although the flowers might be messed up now, but yeah. Okay, so now this layer is actually the frontmost layer, which is good, what I expected, right? That's nice. Nice, yeah, but there is this problem that the flowers actually have the old order. So this is looking messed up still. Right, and I just have to try to save this again. Yeah, it works now. works. Alright, cool. Cool. Okay, so we actually have to pass this layer index along. We have to pass it along. And I guess we could just do a vec3 here, right? As the root. Maybe I'll see how this is used actually. So the root. Okay, it seems fine. We don't really like make the assumption that it's gonna be to the vector, right? We're accessing the components independently, so that should probably be fine. And I just realized something. I will fix that later, though. Alright, so when we're setting the positions here, we just take this Z component of this root here, instead of just 0 initializing it. And the same here, this Z coordinate. Here also, like that. And now when we do this, just add the depth into the Z component, right? Okay, so that's fine now. The flowers are correctly sorted. Very good. Very good. Segmentation fault. Alright, so now we actually have some different depth values for these, but a problem is that it's not actually parallax, right? There's no parallaxing going on here. It's still completely flat, right? So now I need to somehow make it so that the further back a layer is, right? It's gonna be real 3D actually, like, because if something is more far away, it's just how it works, right? So what I want to do is change the projection from an orthographic projection to a perspective projection, right? Maybe there's a nice image for that. Yeah, this is the difference, right? Right now my projection is orthographic, and I want this. Like basically real. It's gonna be real 3D, right? Basically, the only difference is that my three things that exist in this 3D space, right, is just flat planes, right? So what do I actually have to change in my matrix code for that? I assume I have something like a... Oh, I have a perspective projection already. But I really wonder... I think I wanted to parameterize this a bit different. Because I basically want the size still, and I can't really specify that here. So, is there a git link to explore the code? No, there isn't. But yeah, I should really get it up. I just haven't done it. But yeah, there's nothing right now. But I will do that. Actually, that's a good idea. So I wonder how much of this I actually have to read and take in, right? Because I'm not really sure what like the thing is. Like I want the projection plane to be a certain size in the world, right? And that parameterization is a bit different, right? Because if I specify the FOV and the aspect and the near plane, like I can, in theory, figure out what these values should be in order to get my desired size and all of that. But there's probably an easier way of constructing this matrix the way I want it. Right. Like I just want to take this. I don't know the real math behind it, right? So how do I actually make my orthographic? Yeah, it's just scaling it, right? It's just scaling it. The field of view. This is actually by setting the coefficients in the perspective projection matrix. Well, this already happens, right? Like, I don't transform the depth at all right now. Well, I scale it down. Well, sure. Okay, I don't know math good enough, but however, I can just check GLM. Is it, what is it called? Wait, it's like OpenGL mathematics library, right? OpenGL mathematics. So I think the easiest might be to just check this code. I think they have some different functions to generate a perspective projection with some different parameters. So let's see how they do it. So I guess we can search for maybe perspective. Oh my god. This is the documentation. I don't really care, I think, about that. Okay, so this is the FOV. Still. Everything is using the FOV. Like there's probably just a constant factor, like really, that I have to add somewhere in my matrix, but I'm not sure. I'm not clever enough with mathematics to actually derive that. I think, and all of these are using the FOV and the aspect ratio still, right? But I'm pretty sure maybe that's how you have to parameterize it. Maybe. But no, there should be some other way, right? There should be some other way. Because okay, maybe I can do the math. Okay, let's just see if I can make it work first, and then because I want it to be better configurable. Like, I guess what I want is like specifying the FOV and aspect. Sure, it maybe works, but what I want is like for I guess gameplay reasons, right, or design reasons, whatever. I want to be able to specify how large of an area the player should be seeing, right, at any moment. So how I did it here is like I specified basically the height of the camera. So that's 10 units right now. So that, yeah, you're always gonna see the same height regardless, right? And it's nice to specify that with units as well. So if you have an ultra wide screen, right, like this, then you just see more at the corners, and I think that's fine. Like there's really no alternative, right? I could be specifying it in the width, but yeah. Okay, so I guess like using this perspective thingy with the FOV and stuff, that should work at least. So, and I think we should just try that. So that's in the game, I think, where we calculate the camera. Right, so we have this projection matrix, which is the orthographic projection. Let's just replace that with the perspective. And what could the parameters possibly be? I mean, the FOV is gonna specify how much parallax there is, right, in essence. And what's a useful, and like, is this in, this is in degrees, right? Okay, degrees. So the half FOV, right? What is it? Let's do 50, I don't know. Aspect ratio, we have that here, right? Aspect ratio. And the near and the far. Yeah, this might be an issue, right? Because we can't have a zero near plane, that's impossible. Let's make it fairly close anyway. And far plane should, we only need it to go to 1, I think. Let's see what happens. Yeah, can't see shit. Is that because I think I want to try to move the camera back a bit, actually. Yeah, okay, that doesn't fix it, right? I'm actually surprised I'm not seeing anything. could it be? Oh. Let's check render doc actually. Let's check render doc. If we can see anything in the geometry view. So this is the draw call for the world. I'm pretty sure, right? So let's highlight the draw call. Yeah, there's nothing, so it's out of view somewhere. Maybe we can see it here in the VS output. Yeah. The world is behind the camera. Okay. The world is behind the camera. That is unfortunate. And like, okay, we can even see the depth here, right? This is the front layer and this is the back layer. It is 3D. So, wait, what is this view actually? It's like flipped. It's like flipped in so many ways. Yeah, I wonder how I should fix this actually. I mean, I can just... Wait, with World HLSL, how do I use this vertex position? Yeah, I just put it into the view projection, right? That seems fine. But why is it behind the camera? I guess, okay, so I can I just try to move it. I just try to move it backwards. That should be backwards. Oh. Yes. It's like... Yeah, okay, we'll see. We'll move it back way more. And... Okay, why is the depth, like, reversed, though? Why is it? Because the greater... Oh, well, I mean, I guess... Okay, let's do a hack right now. So I guess so the positive Z direction, if I'm using this projection matrix, is towards the camera. And I just made that assumption here, right? So what I want to do, or what we can do, is just basically negate the Z coordinate. Like that. And there is actually some parallax going on, but it's really hard to notice. Yeah, right, because... Oh, this is so bad, like... So like this... it should be like between the near plane and the far plane, right? I just did the assumption that it should be within the scale 0 to 1. So when I fill this, yeah, this depth, so let's just multiply that by 10, right? YOLO. It's a big hack, but... Right. That is parallax. Right. Alright, so... I should be able to add more layers. So if I remove the world again... right, so... If I just... increase this to 4 maybe. Yeah, that is 3D, all right. That is pretty cool. Now, oh, right, the editor camera is still orthographic. Editor is still orthographic. I probably want to fix that. But like, I really don't like this parameterization, right? Like, it's really difficult to figure out what I should set the FOV to and what to set the aspect ratio to, right? Yeah, okay, but let's, like, I feel like I want this, let's see what parameters I need. So, calculate camera, so I need the near and the far and the FOV, right? So let's just pull this out actually. So we'll have something like, let's call that, because I think I want the same camera for the editor, right? I think that makes sense, right? The same kind of depth and stuff like that. So we'll call this camera FOV, maybe, and we'll put this in common. So we'll have the camera FOV, and we'll have the camera near plane, and the camera far plane. Okay, I made that 32. Right. Like that, and now I just have to fix this in the editor as well. There's a calculate camera here also. Just copy paste that. So now, yo. Right, and now now there's all kinds of issues here. So I basically hard-coded, like, oh god. Yeah. Okay, so if I revert, if I go back to the orthographic projection in the editor, wrong one. No, wait, what? Wait. Where did everything go? What? What? Okay, that's back. Right, because like for the editor, what I need to do in order to like edit these vertices, right? I need to find the vertex that's closest to the mouse, and there's some transformation that has to go on there, right? Because these vertices exist in world space in the world, and my mouse is in screen space, right? So I have to transform them into the same space before I can do anything, basically. And I guess what do I actually do right now? I think I actually project the mouse into the world, basically, and not the other way around. I guess it doesn't really matter which way you do it. But I guess the main point, I have to find which vertex is the closest to the mouse, right? And that's gonna be, the mathematics are gonna be a bit different when I have a perspective projection matrix. Because I think if I go into the editor, I basically just hard or hand coded this projection function. Yeah. So this one, project screen to world. And this doesn't even make sense actually, because if we have like real 3D going on, the mouse doesn't really have a position in the world, right? Because the screen is a flat thing. Like there is no depth to the mouse. So what you basically want to do is you want to instead create a ray that starts from the eye or the camera, right, and shoots out into the world in the direction of the mouse, right? And then if you have a ray defined by those 2 points, then you can just check every vertex in the world and easily check which vertex is closest to the mouse or to that ray, right? So I think that's the approach I want to do. And I guess maybe actually the alternative could maybe be to project the vertices onto the screen, and then in that space you could also find the closest vertex. I'm not sure if there's really a difference. Maybe that's easier actually. So if I have some way, well the way is to use the view projection matrix, right? To just project every single vertex and just do that test, right? Right. I just realized I forgot to change the title of my stream. I'm not improving player physics. How do I do that? Right. It's parallax scrolling. Okay, fixed. Right. But yeah, that's, I guess, a problem. And I just hand coded this because if I have an orthographic camera, it's very simple to like figure out where the mouse is in the world, right? It's just scaling and an offset, right? That's all. But okay, so now we have to basically reverse this, and I think actually we could. Okay, let's not discard this for now because I think this is only used. Let's see. So where do I actually... We have like this closest... Right, so we find the closest vertex to the mouse. And what position are we using for this? The world mouse position, right? So that we have to flip that around, right? So for each vertex instead, we want to find out where on the screen that vertex is, right? And compare that with the screen space mouse position, right? And how do I want to do that? I guess one pretty unfortunate thing is that like I can't do any like debug rendering in screen space anymore, basically. Well, I guess I never could, because I would ideally want to like verify the position of these vertices when I project them to have some debugging info, but maybe we can live without that. Sure. So I guess first then, let's change this camera calculation again. So we actually want to use the perspective projection, and also we have to move the camera back. I think we did it by 10 in the game, right? So this is game and edit mode. Yeah. Oh, it actually, like, the movement actually works kinda well. Okay, that's nice. Okay, so I should not touch that. I guess the only problem is finding this closest vertex. Yeah. Right. And I mean, I do. Like, okay, imagine, like, should it actually be the closest one? Because imagine I have this scenario, right? And if I just find the closest one, I would grab it through this polygon, right? Even though I don't see it. But we can start with that. We can start with that, and then maybe we can do some intersection testing. Yeah. Okay, so how do I project a world space point onto the screen? That is pretty simple, actually. Now this is very unfortunate. This is very unfortunate. I should do this to do, actually. I should do this to do, maybe, because or how? Oh, because I literally just to do this projection, I just used this view projection matrix, right? Because this is basically, I mean, it's defined as the matrix that takes a world space point and puts it on the screen, right? So that's, I just need to multiply the point by this matrix. But the problem is that I transpose it because the GPU expects it to be transposed, right? I guess column major or whatever, but let's see. So I need this view projection matrix. I could just put that in a separate function, right? So where do I actually calculate this camera? Here. So yeah, okay. We can just split this up somehow. So we have the camera, right? Oh. And I guess actually we could just put it in here, right? So have something like the projection matrix. And then have some function that just sets this, maybe. And then, yeah, it would. Yeah, okay, let's have all of these actually. Let's just put all of these here. Like that. And then we'll have some function that just takes these thingies, right, and does the calculations here. And then this actually calculating the render camera. We just do this transposing, right? Yes, yeah. So that's just basically a copy, right? And then this should be in a separate function somewhere. Something like update camera matrices, maybe? I really don't like having this. I would ideally want to output these into a separate structure, right? I really don't like having this like ambiguous, mutable stuff going on. But sure, and we only need aspect ratio here, right? That's not relevant anymore. We only need it to calculate the matrices. like that. That's that, and now we like have these matrices around. That's nice. And I guess at the start we just do this update camera matrices, right? And pass the editor camera and aspect ratio. Yeah. Like that. What's issue? Like that. Okay, so now we can actually work with this data, right? We have this now. So. Right, so we don't need the world space mouse position because that doesn't make sense at all. Let's just take the camera out here to have a shorthand for that. Okay, so now let's disable all of this. Finding the edge, let's bother later. Right, so just finding the closest vertex. So what we want to do, we have this vertex position, which oh no, that's a vec2. That's a 2D vector, right? Oh no, right, and the whole polygon has some depth. How do I want to do that? We could just put it in the polygon struct, right? That feels a bit backwards, but I guess we do need this here as well, I guess. So we need to know which parallax layer the polygon is a part of, right? And then the issue becomes, let's just assign that as well. So somewhere here we create the polygon. So just assign that, right? Okay. Is IntelliSense slow? Yes. And I guess also the issue now is that when if we load the world, so deserialize, we're only reading the vertex data and stuff. So I guess let's just assign it here as well. Right, and now the only thing we need is to figure out the actual, I guess, world space depth, basically, of a specific parallax layer. And I already do that in the world here. I do that when filling the triangle data. With this. I really want some kind of shared function for this, right? But for now, let's just duplicate that. That does not feel good. And we'll use the polygon layer, right? So that's the same calculation. It should be in the same place, right? In these places. That should really be a function though. Right. So now we actually do have a 3D position of this vertex. What to call that? I already took the P. Let's call it P2. I guess. Okay, so this is our 3D point now. Right. And we want to put that into screen space. And that is just a matter of multiplying with the matrix, right? With this, we have the camera view projection matrix. That should put the point onto the screen. Let's, I think, wait, Mulvek, I guess let's see what happens. Right, this P, and we have the PP, I guess, the projected point, and actually, like, I have no idea what space this is. It's probably like UV space, maybe, but for now I just want to draw this, like debug draw this point, so to see if I can figure out something about it, right? And the slight issue, I guess, is that this debug rendering happens in world space, right? But I think I might be able to figure something out anyway. So X, Y, and Z, that's gonna be 0, I think. Let's make that white. Alright. I don't. Oh, that's cool. I didn't like see this before, but this, I have this coordinate frame, right, and it's actually showing this z-axis now. Okay, that's. I mean, I don't know what I expected, right? But sure. Okay, so this point. Wait. Okay, in edit mode, right? Right. I'm seeing a bunch of points. What the fuck? Someone is botting me. What the fuck? What the fuck? Someone is follow botting me. What? Why? Why would someone want to spam follow me? What the actual fuck? Are they trying to frame me for botting followers? What the fuck? Okay, let's see. I'm not sure if I can actually figure out anything useful here. And I should make them like make them pink, make them more visible. Right, so okay, I don't think I can make sense of this really, and it's probably the wrong function. Or like, how should I debug this? Like, I can't. Well, maybe actually, if I just print every single one of these, I guess. Do something like 0.1f, sure. 0.1f. Print the x and y of this, and like if I'm, let's see. It's gonna spam a bunch of. And these aren't changing. Okay, that's even more strange. Why? Wait, what? It's not printing anything. What? It should be spamming my console. It should be spamming. Oh shit, right, it's in edit mode, right? Jesus. Okay, so this... It's definitely wrong. It's not like UV space or anything. So this vec3 multiplication. Like I can see the polygon, right? This is that vertex, this vertex is this one, this is that, but it's like not where I was expecting it. But that should be it, right? The view projection matrix. Is this just wrong or what? Like this... Is it something strange like... Let's just try stuff. I think this is not needed. This one you should use if you want to like or project a point from the screen into the world. But let's try this. Infinity. Okay, that's not. That ain't it.
People who commit these acts are in many ways no different from you and me, but they are no longer able to control their urges. They dissociate themselves from their own actions, often
Oh, well. I should negate this. Oh. Oh god, oh god, I did that in the shader, right? Jesus Christ. I have to figure that out later. Okay, it still looks... Still not good. Oh shit. I feel like... I should... Oh, I really want to be able to draw points in screen space, right? Like with the debug renderer. I think and that would improve, like, that would make this very easy, I think. And it would be very useful to have also. So I think I will do that. So I will add that kind of functionality to the debug renderer. So how would that look like? I guess that first of all I just need, so I already split up these into buffers, right? So I have 2 buffers, and I think all I have to do is just add 2 more, 1 more permutation basically. So I'll have 1 collection of buffers for the 3D view, which I can use, yeah, for this box, right? So this is actually in 3D right now, basically. And I want one other buffer, another buffer, that's in screen space. So basically 2D, I guess we can call it 2D. Right. So how do I want to split that up? I guess like I still want the same this kind of buffer IDs or buffer types, all right? So I think I want something additional, something like debug renderer view, maybe. And let's call that view. We have the 2D view and the 3D view, and the 3D view is what we have right now, right? We can draw this player, and he is at like the appropriate position in 3D space, right? And this thingy, right? Okay, sure. Right, and this 2D is gonna be screen space. So how should we split this up? How should we split this up? I think we can just do this basically. View count. Let's make that view count. Is that the right order? I always forget. Well, it should be like that, right? Or is... Oh shit, I think I always get it wrong. So it's... Is it like this? Well, it doesn't matter anyway, right? I guess. So. Yeah, that's a bit... Feels a bit icky to have a 2D array, actually. So we'll first go through the view count. Right, and I guess we'll basically, when we actually flush it or draw, maybe it should be called differently now. But now when we draw, we want to specify which view type we want to render, right? Right, so we call this actually inside of the scene renderer, right? And this is the 3D view. So 3D, right? Debug renderer. Yeah. Like that, and now we should actually, so depending on this view, we're gonna have some different buffers, right? So buffers, And that's gonna depend, yeah, how is this gonna work. So we'll just pick it out depending on the view, right? And then we're gonna pick from this. That makes sense. Well, I'm wondering now, because previously we set... wait, hold on. Where am I? Okay, so when we're actually drawing stuff, we have the current buffer, and we have the current buffer. And this should not actually be a pointer directly to it, because we need to know the buffer ID. Let's keep this global state here, actually. Maybe after the struct thingies. So that the debug render buffer ID instead. Well, okay, wait. Okay, this is... Let's see how I want to do this. Let's actually make this a lot easier to understand, instead of a fucking 2D vector or 2D array, right? So we'll have something like a debug renderer view. Right, and then this is this should be the view ID, right? The view ID, and let's call it the view ID also, actually. All right. So when we flush this, so when we flush, we want to flush a single view, right? So we'll pick that out. Right, and instead of these buffers, we will have those buffers will be inside of the view, right? And it should just be like this again, like that. And the number of views we have, though, let's like this. Views. Well, the debug renderer view count. That's a lot clearer now. Right, so when we actually draw something, we need to know, or we do know, which view we should append the vertices to. Right, because all of these are 3D, right? And we should have some separate functions to draw 2D stuff in screen space, basically. So we can start with the point. So we'll have something like draw debug point 2D, right, instead. So that's the only difference. And let's see. like that. So what should actually the difference be here? We have to pick out the different view somehow, right? So that's why I was thinking we probably need to know the debug renderer. And let's just... So when we create the debug renderer, we're only gonna have a single one, so let's just assign that, right? Let's just set that. We'll do it at the end here, so that's a global. I don't care. Right, and what we actually want to set... and we actually... This is gonna work, right? Right, but instead of the actual pointer to this thingy, it's just gonna be this ID, right? So even more simple here, right? Right, and the difference now is that we have to pick this out now from the current, well, from the debug renderer, and we'll have some... Wait, what? Oi, debug renderer, wrong type. Right, so the debug renderer has some view, and we want to pick out the debug renderer view 3D. In this case, that's it, right? So the difference here is just which one we pick out here. And then in that case, I mean, we guess I can make an internal one, right? Instead of duplicating this code, I could, but let's do it like this for now. So that's fine, and that's how I should do it everywhere, right? This is the 3D, yeah, 3D, 3D, 3D. Seems fine. Okay, so if I want to clear a buffer, I should clear the buffer in all views also, right? So I guess we'll have to do a loop here, right? So go through all views and clear the buffer. Okay. Whatever. So, yeah, okay, so the debug rendering works as before, right? So now, I guess the only difference now I have to add someplace for drawing the 2D ones, like onto the screen, right? And how is that going to be? That's not going to be different, like much. The only thing I have to change is which matrix we are actually using in the shader, right? And for now I use these frame uniforms to store the matrix, which is a bit unfortunate. How difficult actually is it to allocate some new ones? So if I... Oh, I wonder how much I want to split this up, right? Because I guess the easy way... yeah, okay, so instead of using this general frame uniforms thingy here, because the only thing I use is the view projection matrix. So I think instead I actually... yeah, I should just use some different type here. So where's this defined? It's in GPU types, right? So instead of that, let's instead make something like, like a GPU debug uniforms, maybe. Well, debug renderer uniforms. Yeah, let's do that. And we'll have a single view projection matrix still in here. And this should be 64, right? Right, and the only difference now would be that I just create 2 of these, or I allocate space for 2 of these, and just switch out which one I actually bind in these 2 calls. Right. So I flush the debug renderer. Wait. Oh. Wait. So this is actually allocating its own descriptor set. And I guess that's maybe good, because right, so instead of just passing this frame uniform buffer, we should just create that internally. Right. Yeah, okay. I guess that's nice, actually. Right. So... so somewhere here, we already allocate some staging memory, right? Yeah, for the vertices. Right, so we just need one more buffer, or maybe 2. Depends on alignment stuff. Let's make it 2. So we'll call that just uniform buffer. And the uniforms, which will be this GPU debug render uniforms. Right, and we should have 1 of these per view. Right, debug renderer view count. That's fine. So yeah, 1 matrix for the world and 1 matrix for the screen space rendering. That makes sense. Makes sense. So where do we actually allocate this? Here. I like this better. Right. And this is just gonna be uniform buffer. And the size of the debug renderer uniforms. We have to do another loop, right? So the view index, right? Uniform buffer. uniforms. And yeah, the size is gonna be... Didn't I already do that? Uniforms. I think that makes sense. Right, so instead then of this frame uniform buffer, which we passed before, we will just use the internal one, which is it's in the frame, right? Well, do we have the... Yeah, we have the frame. Hello IntelliSense. Right, it has to be like this buffer info. So it has a uniform buffer, and that's going to depend on the view ID. We picked the correct one for the view. This is the offset, which is 0. And the whole size. Right, and now I guess we actually also have to fill this data, right? So we have the uniforms for this view ID, the current view ID. Uniforms like that, and this has the projection matrix, right? And now where to get this from? I think it's just fine if we actually send this in, because in the scene here we do have this somewhere. We have it in we have the camera, I think. Where is all of that? Because we fill the uniforms here anyway. So yeah, okay, SCB camera. So this is the exact same that we want, at least for the 3D rendering, right? So we can send in that after that. That makes sense. Yeah. So the view projection matrix, right? Like that. And we just have to fill that data, get it to the GPU, view projection matrix. And we also have to flush it. Do I have this actually? Staging, yeah. And I guess, it's just like this, right? I want to flush the uniforms and just the size. I already do this here, right? Yeah. I have to flush the vertex stuff, right? Also. Right, and now I have to change this GPU types, so it's this type instead. Let's call it uniforms. I'm not... Okay. Staging memory context was already a pointer. Obviously. Okay, it builds. Segmentation fault. Classic. Classic. What could that be? Let's see. What? Okay, so I messed up something. Staging. I messed up something here. Oi. That's not the right address. Okay. Alright, that was the problem. Okay, and good. We still see stuff in the debug renderer. That's very good. So now let's try to actually flush the 2D buffer as well. And like the only difference there is actually this view projection matrix. That's the only data difference. And what should that be? I wonder if I want to debug draw stuff on the screen, in screen space. I think the most useful space is to do it in UV space, actually. But for now, let's try to just use the identity matrix, actually. So mat identity, right? And that should be from -1 to 1. So it's kinda UV space, but not really. Not really. So I guess now somewhere, let's do it in main. I just have to try this though. So draw debug point 2D. Right. I should really make a better API than just passing the debug vertex. Don't know what I was thinking. But okay, so 0, 0, that should be in the center of the screen. And let's make that cyan. So we should have a point now in the center of the screen. Yes. This point. That's perfect. Perfect. Let's draw some more, because I want to now fit this, change the projection matrix so that it's actually UV space. So let's try to put something at like 0.5, 1. Let's try a bunch of places. Right. Oh god. What the... Okay, something is... Oh, okay. Those points should not be there. They're both in screen space and world space. They're both in screen space and world space. Okay, that's concerning. Yeah, and my character's bottom opens up. Hello. How does this work? I wrote everything in C, and I'm using Vulkan, the Vulkan API, to get the GPU to do things, right? So this is all being rendered on the GPU, right? And I'm using Vulkan to communicate with my GPU and telling it to draw all of this stuff, right? But why is my... okay, that's very strange. So somehow they appear in both the world space and screen space. That's extremely strange. But is it the other way around as well? So if I... no, so the player does not appear on the screen. It's just these points. What could be wrong? So I'm drawing points in 2D and it's selecting the view, right? Oh, wait, oh, okay, oh my god. Oh god, okay, so I am... I'm basically overwriting the staging memory, right? I'm using the same staging memory for the vertices for both views, which is just not good. So I actually have to do this as well. I have to duplicate them for each view. Right. And oh, that's gonna crash, right? Let's skip this for now. Right, and I'll just put this into this loop as well. So for each view, we have a separate buffer, like that. Like that, and we also have the vertices. Okay, so we're only accessing them here, okay, and here, right, and here. Feels a bit messy, but should work. Okay, that's a lot better. That's fixed. I was just overwriting some memory. Right. So now I actually want these points to be I want them to be in UV space. Yeah, okay, so what does that matrix look like actually? Let's try to figure that out. So let's call that screen matrix maybe. Initialize it to identity. And actually, maybe we can do this manually. So, first column, first row. First row, first column. That's like the scale in the x direction, and that should just be like it should be 2, right? And this one should be 2, and there should be some kind of translation. But let's see how this looks first. So, okay, I didn't pass it, did I? No. Right, so that looks fine. So we have this at 0 and 0.5. So we have to offset the stuff as well. And that is in the last row, right? So x should be minus 0.5. Probably. Let's try. It's hard to tell. I mean, maybe this got clipped, right? Or is it 0.5 positive? Okay, this looks. I have to make some better debug test case. So let's say that we have 0.25. So I guess the left top corner, and we'll make these different colors. So this will be red. Red and 0.75. The top right corner should be green. And the bottom right should be blue. And the bottom left should be pink. Right, okay, that is... I accidentally created a skewed matrix of some kind. Is it... That is strange. So it's not these. Probably. Is it like the other way? Let's try this one. Okay, that's okay. If I don't change this, Okay, I guess that's expected, because I scaled everything up. But how do I move it? I guess I can just cheat, basically. So let's say mat translate. We can use my helper functions for this. So screen matrix. And we want to translate it to the left, like that. It's gone. Should I move it the other way? Okay, it's skewed still. How does this happen? I'm just... wait. So if I only translate it... What? Wait. What? If I... Okay, if I just use the identity, right? Okay, that's fine. Like, okay, so like it's basically UV space. Well, it's from -1 to 1, right? So how do I remap this? And like, why? If I treat a translation matrix, like, why is it skewed? Oh wait, I fucking know. Oh my god. I have to transpose this. Okay, that's pretty annoying to have to remember, right? Okay, but I have to transpose it. That makes a lot of sense. Actually. Okay. So that's good. So let's try now to add this scaling back. So we scale it and then translate it back. Okay, that's working. Except for... it's flipped. So if this was UV space, let's see. We put the... So top left in UV space is 0. 0, right? And then if you go to the right, that's increases the x-axis to 1, right? And this corner is 1, 1. This is 0, 1. And I put this red dot. I want it in the top left corner, but it's in the bottom left corner. Yeah. Maybe that's fine actually, but maybe not. I think it's... let's try to actually... Because intuitively, UV space is like that. Like, the origin is up here, right? So let's try to fix that. Scaling should at least be negated, right? And what happens then? Okay, it works, right? So that's working now. So I can actually draw things in screen space now with the debug renderer. That's very nice. Very nice. Why Vulkan and not OpenGL or DirectX? I am on Linux, developing on Linux, so I can't use DirectX for that reason alone. And OpenGL, like you can do advanced stuff, but it like doesn't feel like a well-designed API to me. With this global state and stuff, it's like Vulkan is just more modern, and I like it. I think Vulkan maps on more to how a GPU actually works, and like I like the control also. And I actually like the API also, but maybe it's I don't know. I feel like I like it. But yeah, OpenGL, like you can do modern stuff in it, but it's still like just tacked on, right? Because you can't like remove the legacy and stuff like that. So you're kind of stuck. So I just feel like the OpenGL API is pretty horrible, actually. Do you use C and Vulkan in your job? Yes, I do. Well, I use C++. but we kinda use it like C-style C++ kinda. We don't do modern C++, so it's kinda the same. And yeah, I use Vulkan as well for my job. And I have to say, like, actually releasing a game with Vulkan, it is pretty difficult. Like, to have there's a lot of stuff you have to do to like support things, and there's a lot that can go wrong and stuff like that. Like, I would say, like, if you actually want to release something, it probably is easier to use DirectX, because now also there's a Steam Proton layer, right? Which, like, anyone on Linux can just play DirectX games now with this translation layer. So you're not gonna lose the Linux audience. I've never used Rust actually. The concept doesn't spark joy to me. I have a feeling that a lot of things, like, I would have more hurdles fighting with like the borrow checker or whatever to get anything done. But that's just me. Maybe that's a skill issue, but it doesn't seem fun to me actually. Because programming is all about modifying data, right? So I just want memory, and I want to do stuff with the memory, right? Yeah, I don't like having restrictions on that, really. I feel like I would be slower if I would try to become proficient in Rust. Let's see. So now, okay, so I can draw stuff in UV space. Right, and now what? Now I can actually get back to, well, I saw these validation errors. Maybe I should fix those. Oh. Wait, what? Did I mess up some flag here? Oh, wait, what? How did I? Okay. Wiki buffer usage uniform buffer. Right. Good thing that NVIDIA just doesn't give a shit. You can just... it just works anyway. I love that. Okay. I love it. Okay, but that's fixed now. Oopsie. So, I guess now we can get back to this, because what I want to do, I have this editor, right, where I can move these vertices around, right, and stuff like that. But the problem is the selection right now. It does work if I... can I revert that actually? Yeah, because I recently added a perspective projection, right? That's why you're seeing depth right here. Like, there's layers to this, right? Okay, that's completely broken. Wait, hold up. Okay, never mind. Well, I did have like I can move these vertices around, right? It's a level editor basically. Oh shit! But yeah, now it's really broken because I was assuming an orthographic projection before, so I have to fix my picking code here. So the task is to find the closest vertex to my mouse, right? Because I want to grab these vertices, right? So my idea was to just transform or project, right, these points that are in world space onto the screen, and then just measure the distance from the mouse in screen space, right? So I wanted to debug that because the way you do that it should be pretty simple actually. Because you have this view projection matrix, and that's the whole job of that. Like you take a world space point and put it on the screen, right? That's the whole job of this matrix, of this transformation. So I did that, but now I guess I can actually debug draw these points and see where they actually are, because I want them to be in UV space, kinda, right? And now I can see that that's completely not the case. Okay, I found a point here. Right, so what's going on here, right? What is going on? What is going on? Like, which vertex even is this? It's definitely wrong, right? It's completely wrong. But why? This should be it, right? And it's not like transposed or anything like that. Do I have to wait, I actually have to do a vec4 maybe, multiplication. Let's try that at least. And there should be 1 maybe. I never know with these things. I saw some vertex briefly. Oh, there it is. There it is. But it's just not. I don't understand where it is. Like, what's happening here, right? So, how should I debug this? It should just be this. It should be this. I don't understand. Because this is what the shader does, right? If we go into the world HLSL, there's just a view projection matrix, and we just multiply the vertex position by that. Like, that's it. But maybe you have to do this trickery, maybe. Do this thing. I'm just throwing stuff at the problem right now and seeing what sticks. Yeah, that's not it. Okay, that's... Oh, that is promising. That is promising. Okay. So that's it. However, this matrix puts it into NDC space, not UV space, but that should be simple to fix. So the range of these values now is basically -1 to 1 at the corners of the screens, right? So we just have to scale it down like that. Let's try that first, actually. Okay, and it's obviously flipped upside down, right? Wait, what? Am I... like that, right? Jesus. Jesus. Okay. Okay. okay, it's something. Now I just have to also like, so okay, so we scale it down, which means it's in the range of 1/2 negative to 1/2 positive. So we just have to add 0.5 to both values, and that should be it. Yes. Yes. That's definitely the position of those vertices, right? And be right back. All right. So this is definitely the right places. Right. So what I can try now, actually, because right now, well, okay. Let's actually first try to find the closest point, right? The closest point. So that code is still disabled. So we want. We need the mouse position, and I guess we have that. Yeah, editor mouse pos. And is this mouse pos? This is the like. This is the position in pixels, right? So I also want to convert that into UV space. First, so the world mouse UV, let's call it that, mouse UV. That's just gonna be the mouse pos dot x divided by. Do we have the resolution? Yeah, we have the resolution in here. That's good. Oops. That's gonna be that, and it's gonna be a floating point division, right? And y. That should be the mouse UV, right? Now we can just use this, because now this PP, the projected point, is it is in UV space. So if we just take that now, check the... Oh, we actually have this function now. Wait. I have this vec2 distance, right? Helper. So we want the ppx and y. Like, so we check the distance between these 2 points in UV space and find the closest one, right? That code was there from before. Right, so this should work now, actually. This should work. Right, so I can grab this, and it's grabbing the right one. Okay, that's good, right? That is very good. So editing is working again. Now, the question is, though, the big question, will I be able to edit these background polygons as well, right? Will I be able to do that? That's the question. So, for that, let me check. So how do we do that? I mean, we want to... maybe I could add back this. No, I'll do that later. But I guess, anyway, the first step, right, it would be to just go through all polygons. Hello, hello. Yo. What's up? What's up? I'm adding 3D to my game, right? Look at this 3D. So we have the polygon count somewhere, right? In the world info, we have polygon count. And let's not call this I, let's call this polygon index or something. Right, and then the polygon will just be that one, right? Polygon index. Right, and now these projections are also working, right? So we at least see these vertices on all parallax layers, and oh, it just works, or does it? No, it does not, because we need to keep track a bit more. So we need to, I guess, keep track of. Let me think. Right, so we need something like closest. That's a bit annoying. Hold on. So we have like, we already have the closest polygon, right? State here, so we don't need another state, another variable for that. But we do need. We already have something. We have the closest distance already, and that's like the closest distance within a polygon for all vertices. Yeah, I will not forget. And someone literally fucking spam followed me with his bot army. Like, these 1,000 followers are not organic. Some retard just followed me with 1,000 bots. I don't know for what purpose. I have no idea. What's my syntax error? Right, I didn't. So we need something like. Well, no, I like having closest distance. So this, we can call this instead the closest vertex distance. I think that's better. Right, and then when we're done with this loop, we do have to check if this closest vertex distance is closer than the closest distance, like the total distance. Then we should replace this closest polygon, right? And we also have to update this also. Like so. That seems to be working. Yeah, the only thing I guess is like, okay, I should really wait, draw debug point. I'm drawing some debug point somewhere. Right, the closest. Right, so I should probably like create a function for this, right? That just projects some world space point into UV space. Because I kind of want to do it again here. And I don't really have to draw this anymore, right? But let's move this to a function. So let's call that project project. I already have some name. Project screen to world. Okay, so I guess I call it project world to screen instead. And it's gonna return the UV, right? Right, and all we need is the editor camera, right? We need the camera. That's it. So that's the UV, right? So now we can just use this one here. Like that. Because I also now want to do this again, basically, but for the closest point, so I can like visualize which one that is. Right, makes sense. And what's alright? It's oh god, I need this depth again, right? That sucks a bit, actually. This sucks a bit. But if I do that, yeah. Okay, something is up. Okay, I am just. I need to use this. Okay. Okay, good. But now we can actually see which one is getting selected. But we can, so it's showing it for each polygon individually, right? I mean, it's a bit hard to see, right? But maybe we can. Okay, I might note something useful. Wait. So instead of doing it here, let's just do it after everything, right? So then that state is in the closest polygon, right? So if we have a closest polygon, wait, which loop is this? Okay, I should do it here. Okay. Polygon. Right, it's an editor polygon. Editor closest polygon. like that. So now we should see the absolute, like which one we are going to pick. Yeah. But it's still like hard to see, right? Especially here. It's hard to see which one I'm actually going to grab, right? It is kinda hard to see. So maybe I could highlight it in some way. I don't know if that would help either, but we can try. So I guess we only have, yeah, we have the polygon. So I guess we can just, I think I have this already. So I have some debug rendering for drawing the polygon. Yeah, here. This editor polygon debug draw. I guess I'll just make this public, right? Whatever. I think I have the world interface here, right? Yes. So, oh, I foresee a problem, but let's try that. Right, so it's almost working, right? The problem is that I didn't. I don't specify the depth here, and oh my god, I really need the function for this as well, a shared function. But it's this thing again, right? So actually, let's make it a function right now. So that's going to be something like world parallax layer depth, something like that. And we'll have the like layer index, right? And we want to get the actual floating point depth from that. Debug draw. Let's add it here. And can I? So it's this. Right, so I just, that's a lot better, even though this implementation is still really completely pulled out of my ass, right? It just times it by 10, but it's at least in one place now. So now I can easily use that here as well. So I just need the depth from the polygon layer. Like that. Right, and that's inverted for some. Oh, right. Okay, wait. Okay, so yeah, let's invert this, and then because I did a hack here, so let's remove that, and now it should work. Right. Okay, that's pretty fancy that it actually it's being depth tested, right? But I probably don't want that, and it's still hard to see, right? What's happening? So debug. Is it called debug pipeline? Wait, oh, that's actually in the debug renderer, right? Create debug pipeline. So let's disable depth testing actually in here somewhere. Depth test enable. Disable that. So now I see through walls with this, but I'm not sure if that's better or not. It's really finicky, this. And like, okay, I really have to fix like like when I drag this, it's like not at my mouse. You can see it's a bit off, right? That's really annoying. And I also broke my insertion mode, right? Because I have the possibility to add new vertices also. So I can fix that now, I guess. That's a separate mode where instead of let's see. Instead of finding the closest vertex to the mouse, I instead want to find the closest edge, because I want to find an edge to subdivide, basically, to add a new vertex to, right? And that broke also. So what do I actually have to change here? Right, I basically... So wait, so the vertex position, yeah, this is the only place I have to project, it seems like. So what was that called? Project world to screen, right? And it's really annoying that let's just make it work. But this is ugly as hell, and then I have to call this like parallax layer depth. Oh my god. Okay, this can definitely be improved. Alright, the camera has to be in here. I forgot a brace. Okay. Right, instead of the world position mouse, we use the mouse UV. And that... Right, I guess, so I have some kind of... right, I have the same thing going on, where I want to like draw the selection, right? I will move that out as well here. So we have to check for this, is it in editor insert mode? Yeah. Oh shit. Oh. Okay, I did a debug drawing at the same place, right? Oh god. Time to time travel back and copy this code. Right, so we still need that. that was like here, right? So remove the debug rendering, but we still need this. Okay, that's good. And not here. Alright. And that's wrong because I guess I also have to use the depth here as well. God, this has to be improved. Like I could just keep the depth in the polygon right as a float or something like that. I'm not sure how I want to do it. But let's at least use this function we have now. Like that, and we have to use the depth here as well. Alright, so that seems to be working. So, or is it? Not really. It's not really working. Because this edge, like, it's definitely the closest one here, right? So why is this broken? Why? Right, of course. Wait. Okay, of course. Oh shit, like, I'm... How is this, like, variable shadowing not just an error? Like, when is this valid? Like, Jesus Christ. Okay, but I accidentally redefined the variable, right? So... closest edge... blah blah, closest. That should be it. It's not. Edge length. All of this should be fine, I feel like, because it's in. All of this is in screen space, so like the same calculations should still work, right? Oh. That's it, I think. And like this is the closest edge distance. Okay, that seems to be working. Right. So now I can just pick one of these and subdivide it. Add a new vertex. Yeah. But God, it's really annoying that the actual dragging is off. It's kinda off. And okay, I really feel like I should I could maybe simulate, because these like they blend together, right? It's not really like visually it doesn't look like any more like a background than the foreground. It like catches your attention, right? So I want to desaturate it somehow, I feel like. I guess a very simple option would be to darken it somehow. And I guess actually we could do something in the shader. So we can make some maybe some fake fog, maybe fake mist or something. And we should be able to do that just using the depth. But what depth is the question? I don't want to use the vertex position directly, but what if? I mean, in the fragment shader, I have this the like actual depth, right? That's about to be, or that goes into the depth buffer. Maybe that's fine. Let's try that. We have like the input position, right? And do I have to do this? Let's try that at least. So let's try something like okay, we'll take the albedo and lerp from the albedo to some kind of maybe white. Actually, mist is white by the depth, and I'm not sure like how this is gonna look. Okay, so apparently the depth is big. Let's divide it. Okay, it doesn't seem to be like very. Okay, there is some bit difference. There is some difference, tiny. This foreground layer is a bit darker. I need some curve or something like this. Yeah, it's not. Maybe I can make it exponential. I don't know like what the. I think this is really not. I guess it would be nice to have the linear view space depth. Okay, I probably should. But I need some curve. Alright, so I guess let's take the power. It's so slightly noticeable. Okay, interesting. Okay, that's too much, I guess. Okay, that's a tiny bit better. Very tiny. I mean, that's too much. I guess I want to do something like this is so hacky. Magic values. Okay, now it starts a bit. Now it's a bit like you can at least distinguish these, I feel like. It's a bit unclear still, right? Maybe if I increase this coefficient now. I should add shader hot reloading, I feel like. Just like, I guess this could be like a mountain or something. Well, it's not that far back, but... Let's add some scenery. Right. Whoop. I feel like something I need is I need like kind of different some kind of materials, right? Right now everything is the same boring brown, right? And the same flowers everywhere. I want to somehow be able to specify a material, maybe on an vertex per vertex basis or something, or like you can maybe say like, oh, on this edge there should be rocks or something, and then it doesn't spawn flowers but maybe spawns some small pebbles or something like that. Yeah, I want some more variety. And this like Parallax, it's hard to know what scale, like how much you want, right, as well. And I really want to make that more configurable, because all I can do now is, I guess, alright, I parameterize this, so I can increase the FOV, which will make it look like... what effect will that have, actually? I think it will make it so that... Right, it looks like stuff is farther away, but I mean, if I increase the FOV, I also have to compensate, right? I have to zoom it in, basically, right? So that it covers the same area. And that's really... like, I have to compute this in some nice way. I have to figure out the trigonometry, right? But I guess let's have something like camera offset. And right now it's it was 10. Let's try 5. And that should be here. Right. Well, I think... yeah, I'm not really sure like what effect that has, like intuitively. So if I increase the FOV, that means that what does that mean? I mean, there will be more of a parallax effect, right? And maybe that actually doesn't have an effect on how close things appear to be. Because this mountain or whatever still looks like it's really close, right? It doesn't look like a mountain, right? But I wonder if the FOV and stuff alone can change that. And like, I can try increasing the spacing of these so that it actually does so it actually is further away. So right now I have this magic 10 value. So now that's further away. but it's still like I'm gonna need way more layers, I feel like, because it still appears to be really close, right? So what if I change the FOV again? I can experiment a bit with the... Oh. I feel like it seems closer now. I feel like that's the case, right? When I decrease the FOV. Yeah. So then in essence, I guess, so what was it? It was 80. Was it 80? Okay, so that's the total FOV. So then my max is... Well, what's my max then? Let's try a crazy number, right? Okay, yeah, definitely. Okay, so if I increase the FOV, this appears a lot farther away, right? And then I guess that makes sense. So right. I guess I need to find some sweet spots, and I really want to parameterize this a lot better, right? I guess I want some kind of... because regardless of how much parallax I want, I still want the camera to see the same area of the closest layer, right? For gameplay purposes, right? So I want some kind of value I can slide up or down to have some parallax factor, right? And then there should be some code that calculates the FOV from that. Or maybe I can just specify the FOV. That's kind of the same thing, right? But the problem is then finding how close the camera should be to this first layer, right? That's what I have to calculate somehow. And it should be pretty simple actually, with some trigonometry, right? If I have the FOV, it should be simple enough. But I feel like this is a bit extreme, right? Well, maybe if I decrease the layer distance, maybe it's fine. And I guess there's really no difference. Like, yeah, there is no difference between increasing FOV or increasing the spacing of the layers, right? That's an identical operation. I feel like that, at least. I feel like that's the case. So maybe I shouldn't go that crazy with the FOV. Yeah, so I think I have to add more layers. But I think I will do that later, at a later time. Because then I also have to... I want to add... I guess it's backwards compatibility, right? Like I don't want to discard my world save file, right? I would have to do that now if I increase the number of layers. So I have to figure out something there.
You don't stop and look around once in a while. I miss it.
Yeah. And it doesn't look that interesting, right? I want some kind of different materials instead of dirt with grass on top, right? I guess I can remove this debug drawing as well now. Alright, but that's... I guess it's a good first step at least to adding parallax scrolling. Yeah, and I just noticed a problem. my player is affecting the grass in the background. So I definitely have to do something about that as well, because that does not make physical sense. Right. Surely. So what's the diff look like? Right, I added screen space debug rendering. Yeah. And something else, I don't know. Add screen space debug rendering. Yeah, I don't know. Probably something else also, but whatever. But that's it for now. Anyway, I hope I will see you later. Bye bye. Have fun.